Hello viewers, my name is Zansiwengayo from Zomche High School. Welcome to the ECDoE broadcast studio. Today's lesson is about organic chemistry. I'll be covering 3 subtopics back to back for your full understanding, starting with the nomenclature. In grade 12 content, you actually focus on 8 homologous series. However, we'll be focusing on the 3. We'll be looking at our alkanes, as well as alkenes and alkynes. So all these 3 have got something in common, the fact that they consist of only carbon and hydrogen atoms in them. Now, the structural formula for your alkanes is actually carbon, single bonds, all single bonds, carbon. The general formula is CnH2n plus 2, which means that all your alkanes will always follow this general formula. So if they follow in this general formula, this means that if you have got your alkane, which has got 1 carbon atom, to actually name it, we're going to fill it up with hydrogen atoms. So its molecular formula will be C in the place of N, we put 1. H2 in the place of N, we put 1, plus 2. This means C1H4. But we can omit the 1 and it will be CH4. This is your simplest alkane. Now we can also focus and we can move forward and look for your possible alkanes with a straight chain having 2 carbon atoms. So our prefixes are 1 for math, you look at the carbon chain, and then 2 for F, 3 for prop, 4 for but, 5 for pent, and then we have 6 for hex, 7 hept, 8 for oct. This is where we stop in the grade 12 syllabus. We only go up to 8, longest chain. So this means that our longest chain will be having either of these. Now, when you have got 2 carbon atoms in the longest chain, and then you fill them up with your hydrogens, let me move that a bit. You fill them up with your hydrogen. Let me remove this because now it looks like it's another bond, and it's not. So let me quickly remove that from the top. Now we have got this. Then the carbon number is 2. So now the molecular formula would actually be C2H2 times 2 plus 2, which is equal to C2H6. Now, how do we name that? We said for 2 carbon atoms, we use F. So that would be F. And now for your alkanes, the prefix becomes the carbon number, then the suffix becomes A and E without the S. So this would be an ethane. Now, if you are looking at your alkane with 3 carbon atoms in it, 1, 2, 3. One, two, three. Now for our prefix, there's 1, 2, 3 carbons. So our prefix would be prop, and then our suffix would be A and E. So our simplest alkane would be propane. Then our alkane with 3 carbon atoms would be propane. Now for your alkane, which have got 4 carbon atoms, 1, 2, 3, 4, in the longest chain. Like I said, we are focusing on our straight chains. So this would be a butane. But for 4 carbons. And then how do you write its molecular formula? C4H4 times 2 plus 2. Therefore, this is C4H12. So your butane would have a molecular formula that's C4H12. And how do you name it now? But for the carbon chain, which is 4, and then A and E for indicating that it is an alkane. So yes, let's recap a bit. For your alkanes, we said firstly, your alkanes will always have a suffix of A and E. We said 1 for math, 2 for eth, 3 for prop, 4 for but, 5 for pent, 6 for hex, 7 for hept, as well as 8 for oct. So these become your prefixes all the time. Whether it's an alkane, it's an alkene, or an alkyne, you use the prefix. But your suffix for your alkanes will always be A and E. And the functional group for alkane is carbon single bonds, carbon. All of them. Now we move on to the next homologous series, which is your alkynes. So we focus now on your alkenes firstly, then lastly we're going to do alkynes. So with your alkenes, the general or the functional group for your alkenes is carbon double bond carbon, which means that all your alkenes will always have this in them. A carbon double bond carbon, at least one of them. Now, let us actually make up compounds with an alkene. Your simplest alkene would be carbon double bond carbon. We fill with 4 bonds, hydrogen atoms. Now, because we have got 2, we said previously that 2 carbon atoms, we say the prefix would be F. And now, because this is an alkene, alkene suffix would always be E-N-E, which is ethene. This is now the molecular formula. The general formula for your alkenes is CnH2n. Then that means that for every alkene, they will always follow this rule. So when you have got 2 carbon atoms in an alkene, it will be C2H2 times 2, which is C2H4. That is your molecular formula, C2H4. Then the name would be ethene. Now let's look at when you have got 3 carbon atoms in the longest chain. We are only focusing on the straight carbon chains. Now we have to have a double bond, at least one double bond between carbon atoms. Now let's fill up with our hydrogens. Because of the fact that we have more carbons in the chain, so we have to number the carbons. We can number them from left to right. And one of the rules is that the functional group must be closest to, have the lowest number possible. Now, if you are counting from your left to right, you would have your double bond between carbon number 2 and carbon number 3. But if you are counting from right to left, let's use another pen. If you're counting from right to left, this would be carbon 1, 2, 3. So it would be let's say right to left. This is carbon 1 and 2. So the lowest number we have got there is actually between 1 and 2. So we have to stick to 1 and 2, because remember, your functional group should be having the lowest number possible. So this would be 3 carbon atoms would be prop. Then the double bond is between carbon number 1 and 2. So it will be prop 1. It will be prop 1 in. Let me erase that. Prop 1 in. So this would be the correct name. We will not use the left to right, because from left to right you would have prop 2 in, of which that is not giving us our alkene the lowest number possible, because we start counting, numbering our carbons, that will give us the functional group having the lowest number possible. Now let's look at the general formula. General formula would be C3. So we've got C3H2 times 3. So now this means our molecular formula will be C3H6. So the prop 1 in would be having C3H6. Just to go through a bit more, we can have 4 carbon atoms in the longest chain. So when you have got 4 carbon atoms, you have got 1, 2, 3, 4. The double bond can actually be between these 2 carbons, or can be in between the carbons in the middle. When you have it there, you would name it differently. Sorry, you won't have another one there. Then you have got hydrogens here. We fill with our hydrogens. Hydrogens there, the 3 and the 2 hydrogens. Now each carbon is surrounded by 4 bonds. Now if you are numbering this from right to left, you would be having 1, 2, 3, 4. That means that the double bond is between carbon 1 and 2. If you are numbering it from left to right, it would be 1, 2, 3, 4. Now, this means that your double bond is between 3 and 4, whereas for the first time it was 1 and 2. So we're obviously going to choose 1 and 2. So to name that, because we have got 4 carbon atoms, so the prefix will be but. Then the double bond is between carbon. The double bond is between carbon 1 and 2. So this will be but dash. We always put a dash, a hyphen in between a letter and a number. But 1. It's but. Let me move that a bit up. But 1 in, which is the suffix for your alkenes. So just to summarize a bit, for your alkenes, the suffix is always ene, and then we give the position of the carbon number in which we find the multiple bond in. I will now recap on the last topic. We were actually looking at the alkenes and how to name alkenes. Now let us summarize the key points in our lesson. We said that for your alkenes, that the suffix becomes ene. We also take note of the position that the carbon numbers is found in. Now, we are actually moving on to your alkynes. Let's now move on to the alkynes. With the alkynes now, also that. With the alkynes have got the structural formula for the functional group, which is carbon, triple bond carbon. And the general formula for alkynes is CnH2n minus 2. So this means that all your alkynes, everywhere you find them, they are actually following that general rule. Now your simplest alkyne that you will find would be an alkyne that consists of 2 carbon atoms. So let's draw the structural formula for that. It's carbon, triple bond, carbon, and then hydrogens. So to write the molecular formula for that, it would be C2 because there's 2 carbon atoms, and then H2n minus 2, which is 2 times 2, which is 4, then minus 2, then it would be C2H2. This is actually the molecular formula for your alkyne. Let us name this alkyne now. We said if you have got 2 carbon atoms in the longest chain, then the correct prefix we use is F for 2. So this is F. And for your alkynes, the suffix now becomes Y and E. So we say if, we put F, and then we say this would be ethyne. Now let us look when you have got your 3 carbon atoms in the longest chain. You will have 1, 2, 3. You put the triple bond, then you fill your carbons with your hydrogen atoms. Okay, now that is an extra one. So we have got, then from the general formula, it's CnH2n minus 2. So now the molecular formula will be C3H2, this should be 2, H2 times 3 minus 2. So it will be C3H, 6 minus 2 will give us a 4. So our alkyne with 3 carbon atoms is going to be C3H4. Now let us name that. To name that, you actually have to consider that your carbon numbers must be closest to the side which has got the functional group. Functional group is closest to the right-hand side. So you're going to number it from right to left. When you're numbering it from right to left, this would be carbon 1, 2, 3. Then the triple bond is between carbon 1 and 2. But when you're numbering it from your left to the right, this would be 1, 2, 3. For left to right, and therefore we're gonna be having 2 and 3. So we're not gonna use that because it gives them the highest number. We must always give priority to the functional group. So the correct name there would actually be prop, which is the prefix for 3 carbon atoms, and then between carbon 1 and carbon number 2, we've got a triple bond. So we say prop 1I. This is how we name it. Then, if you have got 4 carbon atoms in the longest chain, then you would have 1, 2, 3, 4. If your triple bond is more on the inside, meaning between these 2 carbons, if you're counting from your left to right, this would be 1, 2. If you're counting from right to left, we use another pen, this would be 1, 2, 3. Now, triple bond is between 2, 3. Triple bond from left to right is between 2 and 3. So you can see whether you start from the right to the left or from the left to the right, in this case, it will still be between 2 and 3. So that means that the naming, if this is the compound, your alkyne, it would be, let's fill up the bonds to make sure that there's 4 bonds surrounding each carbon atom. So this would be hydrogen, 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 and then hydrogen, hydrogen, hydrogen. So now this is C4H2 times 4 minus 2. Minus 2. Then this is actually C4H, 2 times 4 is 8 minus 2 is 6. C4H6. So this means that your alkyne with 4 carbon atoms will always have a molecular formula of C4H6. Now let us name that. That would be but for the 4 carbon atoms in the parent chain. Then the triple bond is between carbon 2 and 3, so we take the lowest number 2, and then we put Y and E as the suffix. So we say but2I. Now let's recap a bit. We said that we give priority to the side closest to the functional group, and our suffix for alkynes will always be Y and E. Now let us summarize the key points in our lesson. The key points is that for alkanes, when we're naming alkanes, we actually say we put the prefix, which is the 1 for math, 2 for F, 3 for prop, 4 for but, and 5 for pent, 6 for hex, 7 for hept, 8 for oct. Then the suffix for all your alkanes will always be A and E, whereas your suffix for all your alkynes will always be Y and E, and your suffix for all your alkenes will always be E and E. Now, when you get to your alkenes and alkynes, you have to consider the numbering of the carbon atoms. You will have to start from the side closest to the functional group, giving the compound functional group the lowest number possible. And also, between a letter and a number, we put a hyphen. That is all for our lesson for today, focusing on your hydrocarbons and naming hydrocarbons. We have come to the end of our lesson. Thank you for watching. See you on our next lesson on ECDoE Broadcast Studio. You can leave your questions on the comments. Don't forget to leave the name of your school so we can give shout outs. Please share, recommend, and subscribe to our YouTube channel.